Okay, hi everyone. Conferences have changed a little this year. We're doing a lot of virtual conferences, which is really cool to me because it means we can do more of them. So my name's Josh Stella. I'm the co-founder and chief technology officer at Fugue. And what we do at Fugue is cloud security. But what I'm going to talk about today is Open Policy Agent, addressing cloud security with, as they call it, OPA. So a little bit of what we will cover on the agenda. I'm going to go through an overview of misconfiguration risk in the cloud era. This is the big attack vector on cloud is misconfiguration of cloud resources. I'm going to explain that a little bit. Why we believe policy as code, which is what OPA does, is really mandatory for successful security and compliance. Manual processes just don't cut it anymore. I'm going to go into an introduction of OPA and show you their website and talk a little bit about the language and so on, and some of the ecosystem of tools that Fugue contributes to quite a lot. We're going to drill in to the OPA toolbox for the cloud security use case. OPA gets used for all kinds of stuff now, but we're going to drill in for cloud security. And then a little bit on getting started with policy as code using OPA. Now this is pre-recorded, so we can't take live questions, but I hope this is at least a really good introduction to the topic. So what is cloud misconfiguration? The first thing to understand about it is a major security risk, the major security risk in cloud. So nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes, according to Neil McDonald from Gartner. Gartner just last week put out some new research saying that cloud misconfiguration is a greater threat, is a greater attack surface, a greater vulnerability than workload security, which is all we used to care about. So this is a big deal. Now, we at Fugue every year do a big survey of folks who are operating at scale on cloud. And this 93% figure came from that survey, over 300 companies and organizations operating at large scale on cloud, and 93% were concerned about a major security breach due to misconfiguration. I was pleased with that number, but the 7% that aren't represented, probably going to show up in the news. If you're not worried about this, you should be, because even the experts find it quite challenging. And by the way, before founding Fugue, I worked at AWS as a principal solution architect for national security kinds of environments. So this is a huge problem. Now, if you were to read the news, and if the news were fully accurate, you would think that object storage access policies, object storage, would be the #1 misconfiguration concern. But when we ask people what their main security risk concerns are around misconfiguration, the very first answer was identity and access management. And I was super pleased to see this, because that's true. IAM is really a network, is the right way to think about it. And getting it correct is extraordinarily difficult and complex. And if you get it wrong, it can have just devastating consequences. So #1 answer, IAM, obviously they're not exclusive of each other. #2 answer, security group rules, but essentially firewall rules, TCP IP based ingress and egress. Yeah, we usually, one of the things that I get to do, it's a lot of fun, is when a breach hits the press, I and my team will try to recreate it. You don't always have enough information to go on, but you always learn something. And one of the things that we've learned is that most of these breaches are a combination of a problem with IAM, a too liberal ingress port somewhere, and then ultimately getting to the object storage access policies to steal data. Also, a very common hack is, stealing data at a S3 is kind of the one everyone talks about, happens. Rarely because it's just a public bucket. So that is a simple interpretation versus the reality. But people also do stuff like stand-up crypto mining in your cloud accounts. There's all kinds of things they can do. And then fourth among our respondents was encryption in transit disabled. All right. So what we've learned over years of doing this, and this is kind of all Fugue does, is that cloud misconfiguration is pretty much universally overlooked in some way or another. That I have yet to see an organization that had it perfect. And there are reasons for this, valid reasons. That quote from Gartner sounded a little pejorative of cloud users, of customers of cloud. It's actually very hard to get this stuff right. So every time somebody hits the news, I feel bad for them. I don't think they're fools. It's hard. Many dangerous cloud misconfigurations are not recognized as misconfigurations by the security team. And there is a reason for that, which is most security teams are at least somewhat reliant or heavily reliant on compliance frameworks to give them guidance, best practices. There's NIST, there's SOC 2, there's CIS benchmark. Well, those are behind the times. And so all kinds of dangerous misconfigurations can exist even when you're doing things right according to those standards. So the security team doesn't see it as a misconfiguration because the compliance framework they're reliant on doesn't see it as a misconfiguration. And therefore, they are exceedingly common in enterprise cloud environments. And because of the changing nature of cloud, the constant mutation of infrastructure in cloud, this is akin to needles continuously appearing in a haystack. So a little bit about hacker strategy. And by the way, all these things relate back to policy as code. So stick with me here. Hacker strategy has evolved over the years. Kind of the traditional Hollywood version of bad actors breaking in and stealing your data is that they first identify the target organization, and then they search for vulnerabilities or maybe use like phishing or something to create vulnerabilities and then attack and steal data. This does still happen in the world. A relatively recent example of this was North Korea did not like a movie that Sony Pictures made, and so stole their email, and they targeted Sony. But this is not how most main real breaches happen anymore. What instead is happening is that the bad actors, often in organized networks or distributed networks, are running automation to find misconfigured resources. And a friend of mine who just focuses on this area told me that the average length of time between a resource going on the internet, an IP address or a DNS record or whatever, and it getting scanned for vulnerabilities is about 7 minutes. Once it's found, the bad guys are going to hit it even faster than that. I've seen as fast as multiple times a second, where bad guys are examining your critical infrastructure that's internet facing, looking for those ways in. So what the bad guys do is they run all this automation, they constantly run it, and they get up in the morning and they get their coffee and they see, oh, there's a bank with a vulnerability. Oh, there's a major manufacturer. And then they already know what the misconfiguration is and how they can exploit it, because that's what their automation was looking for. So if you don't think people care enough about your organization for them to target you, it doesn't matter. As soon as you're putting things online, bad guys are finding them. And if you have anything they care about, they know, they have an enumeration of what you're vulnerable to. And this is why I said earlier, the manual approach is no longer good enough. It's just simply not fast enough, and it's not thorough enough, because the bad actors are using automation, and you have to use automation. And policy as code is a really super thorough and helpful way to do that. So the attack surface on cloud is complex and ever expanding. So in the data center days, you had, there is still physical infrastructure in the cloud, but that's all abstracted away by the cloud service providers, right? But in the old days, you would buy switches, you would buy servers, you would buy firewalls, you'd shove them in a rack, and 3 or 5 years later, you might recapitalize those. These things were, replace them. In other words, pretty static, right? Pretty static. and they were manually deployed, configured, and maintained. That slow manual process gave all kinds of teams the time to examine that infrastructure for security and other reasons, because it moved slowly. I mean, I've sat in change control boards. We were talking about, which ports should be allowed to be open on a firewall, and there's some canonical document that says this is what can be allowed, and there's a team who own that. Well, the cloud's completely different than that. You can try to do that in cloud, but you'll fail. I've seen organizations try to treat it like a data center. It doesn't work. Engineers are smarter than that, and they find ways around your slow-moving controls. The whole point of cloud is to go fast. And so you have software-defined infrastructure, which is highly dynamic. And all of it is deployed, configured, and maintained via APIs. Now, those APIs giveth and taketh away. What they give is this ability to go as fast as you want, to experiment, to iterate, and that's awesome. And that's one of the key benefits of cloud. The APIs also give us the ability to use software engineering and computer science to check the efficacy and safety of our infrastructure. You could not do that in the data center. It was manual, right? So, but those APIs also take away the friction, the slowness for manual checks to be effective. So the developers themselves are now building and modifying their own infrastructure environments. So this is why we believe strongly that you have to use policy as code for any kind of security at scale on cloud, because in the data center days, the infrastructure, security, operations teams would build out infrastructure and then hand resources off to the business units that were building applications, and validations and audits were generally performed infrequently and manually. And the data center never had a control plane API that was complete, right? So in the cloud era, this gets flipped upside down. Instead of the developers getting slotted into existing infrastructure that's run by the infrastructure teams, the developers are ad hoc building infrastructure. I built this morning a global network in about 5 minutes. Well, that would have been a months-long project in the data center world. So, and this is a reality we just have to deal with, because it is going to continue. So the world's flipped over. Now the developers are building the infrastructure via APIs. But we gain the ability, now you can still do, and we see this all the time at Fugue out there in the world, folks that are still doing manual validation, audit, remediation, but it's kind of nuts because the bad guys, remember, are automated. So what you can do now is use policy as code in order to go as fast or faster and be preventative against these kinds of risks. And what this really does is the policy as code then empowers engineers to own the security of their cloud-based systems successfully. You can make it repeatable. You can make it testable, shareable, scalable, peer-reviewed, all the good stuff you get when you're talking about writing code. All right, so what is policy as code versus other things? In traditional programming languages, general purpose programming languages, what you're really doing is expressing, some kind of logic and data manipulation, right? Data processing and logic. So your logical functions, and I mean this with a small f, I don't mean formal functions, although those two, are expressed as code. And then your tooling, your compiler, your interpreter, your linter, your IDE provides a feedback loop that tells you whether it is going to work, or at least give you a lot of hints, right? If you try to multiply a string times a floating point, your compiler or interpreter will probably at least tell you that you might not be wanting to do that. That's going to have a weird result, but probably will tell you you're not allowed to do that without a cast, right? So a lot of people think, who aren't programmers, and my background is in programming and software architecture, think that programmers are people that have this big complex machine in their head and they just write it down. It doesn't really work that way. The way it works is you're trying things and your tooling is telling you where you're making a mistake. Not all mistakes. You still have to have a lot of judgment and a lot of taste and your own opinions. But the tooling is helping you along the way, every step of the way. Well, policy as code is that same feedback loop around security. So your security posture can be expressed as code. And then the tooling can tell you if what you're doing from a security perspective is correct or dangerous. In the same way the compiler interpreter will tell you if your functions will function, a policy as code engine, a good one, will tell you if what you're doing is secure and meets policy. And by the way, this is an immediate gain in terms of productivity. Because if, as a developer, if my tooling is now telling me, hey, you can't have that particular port open to the whole internet on a security group, I don't have to wait for a security audit to tell me that. My tooling tells me that, and I can fix it without any humans getting in the loop. So really powerful stuff. So we at Fugue are super excited about Open Policy Agent. We actually have a lot of formative patents in the area of policy as code at Fugue and had written our whole own compiled language around it and so on. But then when OPA came out, and that's what the creators call it, OPA. When OPA came out, we saw what had the potential to be a standard. And there really has never been one. There have been some absolutely horrible XML expressions of policy that don't do anything. It don't have any functional aspect, any runtime aspect. But in terms of like an actual working open source standard, and I don't mean standards body, I mean de facto standard agreed upon by a lot of folks, that's never been the case with policy as code. And we saw OPA as a potential real win in this area. It's also very good. And I don't, you know, a lot of times technology pops up that we look at and I think, yeah, OPA's really nicely done. It's pretty elegant. It really started taking off when it became sponsored by the Cloud Native Computing Foundation, who are the folks that manage Kubernetes. So when we got on board, it was real early days. Now a whole lot of folks are using this, like Pinterest and Netflix and all kinds of people. I went out to give a talk at the OPA day at KubeCon last year, and it was standing room only. And, you know, all kinds of big companies there. Okay, OPA has a language called Rego. I don't know why people make naming choices, but the language has a different name. It's Rego. It's a really cool, simple language. It's really declarative. And it's sort of like a query language. In fact, I think of it as a query language, but a declarative one. And it can validate any JSON data structure. Well, just about everything can get expressed as JSON these days. So you can compare that using OPA and using the Rego language. You can assert declarations about what you expect and don't expect there to be in JSON. And then it will examine it and tell you whether or not that's true. And that means you can use this for a whole lot of use cases. So the normal ones that I saw out at KubeCon and that I read about all the time are people using OPA on a transaction basis in microservice architectures, where individual calls from microservice A to microservice B to microservice Z are getting evaluated as to whether or not that call is legal. We use it in a totally different way at Fugue. We use it for cloud configuration of cloud infrastructure. And it scales really nicely. We do over 1 billion evaluations of policy a day in our SaaS platform. We have added quite a bit to the tooling ecosystem, which we'll show you. We've got an open source project called Regula for checking Terraform using OPA. And we've also got a much faster evaluator and better dev tools, breakpoints and stuff like that. Okay. I'm not going to read through this, but until OPA, you really kind of had 3 choices. 2 are shown here. One was a proprietary policy as code, which was usually expressed as some kind of pseudo language baked into a vendor's product, often a kind of subset of SQL or something like this. And it was specific to that product. You still see that now with, you know, lots of vendors out there. Oh yeah, we do policy as code, and you look under the hood and it's something that only works with their stuff. There are all kinds of problems with that. We as an industry are familiar with those. The second one we don't have on here is people trying to build policy libraries into general purpose languages. I personally have seen a lot of these, and I don't think any of them are very good. And the reason is this is its own domain. And it can be done much better with a domain-specific language, which is what Rego is. So Open Policy Agent, I mentioned you can use it across lots of use cases. There's a robust ecosystem and community that's only growing, and that means your engineers will want to learn it. Whereas if you tell an engineer, go learn some proprietary language that's, you know, baked into some big enterprisey product, that doesn't usually, unless it just becomes absolutely dominant, doesn't usually become a good career skill. But OPA is a pretty good career skill. All right, a myth that needs busting is that to do policy as code in the cloud, you first have to do infrastructure as code. That's not true. You can do policy as code right now, no matter how you built your cloud infrastructure. In fact, it's important to get it in place. If you haven't gone to infrastructure as code yet, it's important to get it in place up front. Also, very few organizations standardize on single infrastructure as code products. You might have some Terraform and some CloudFormation and some Ansible scattered around an organization. Well, if your policy as code is dependent on infrastructure as code, you now need that many policy as code solutions with different policies and rules. It's a really bad idea. So, well, you want to check policy up front, but you need the same policy to work all the way through into the runtime. Yeah, so we believe that policy as code really has to take priority over infrastructure as code. I mean, by all means, do both. But policy as code can be its whole own separate project. Most of our customers that are implementing it do it that way. They don't go and impose on the team that's building out Terraform stuff to do policy because it's a separate concern. And they just offer it as a service. And then ultimately over time, it becomes important enough that it's mandated. All right. Where you need policy as code is throughout the entire software development lifecycle. And they have to be the same policies, like literally the same files, the same Rego files in OPA's case. Otherwise, you're going to get different results at different stages, and that is going to sow confusion and create vulnerabilities. So what do I mean by the whole SDLC? You got to start in design, or at least you want to, so that, like, for example, we have this project called Regula that's out on GitHub. I'll show it to you. Open source project, and it will check your Terraform plan files against OPA policies. Well, the same OPA policies can then be loaded into a CI/CD pipeline. So first you check your infrastructure as code if you're doing that. But next, in your CI/CD pipeline, you can check the dev environment post-deployment to see if it's valid and should be allowed to go to stage or prod, right? So you can gate your deployments using policy as code. And then finally, you're not done yet. That's all the day one stuff. It's day two on that is hard in this industry, right? Any of us who built stuff know that. So you have to be constantly checking against those same policies, against that infrastructure, because the stuff is mutable, right? Somebody can have a maintenance window and go in and make a change, and that's not in your design or deploy stage, but now it's in your production. And maybe it's a dangerous change. So you need it the whole way through. I would argue you absolutely need it in the enforce, and I would go enforce first, then deploy, then design, unless you want to go across the board. It's really not that hard. All right, let's switch from slides. I normally spend a whole lot of time at the terminal, but this is less a live demonstration and more a talk on a topic. So I apologize for all the slides. All right, what I'm showing you here is actually our diagrams that we generated in Fugue. And the reason I'm showing this is to contextualize how we're using OPA for cloud configuration. So just to make clear, what Fugue is going to do in this case is go scan your whole environment, collect all of the configuration information, and then we can do computation on it, such as drawing diagrams, and comparing to OPA policies. So just a little explanation of what you're looking at. This is the internet. It's going into some different VPC networks through internet gateways, load balancers, compute instances, etc. All right, and if I select one of these things, I can get all of its configuration information. However, using OPA, I can show errors in compliance. So a bunch of stuff just turned red. Those are things that are failing our policy as code evaluations. Okay, so let's take a look at this VPC network. You can see down here, VPC default security group should restrict all traffic. Configuring all VPC default security groups to restrict all traffic encourages least, I'm not going to read the whole thing. Basically, every time you build a VPC on AWS, if you didn't know this, you get with it for free a highly insecure security group, okay, that allows egress on all ports, which is a really bad idea. So we're telling you that. And the way we're telling you that is by evaluating OPA, a rego policy against that infrastructure. Okay, so this is one way. And by the way, there's a version of this that is free forever for small scale deployments. You can go to fugue.co and use it for free forever. I think up to 1,500 cloud resources, something like that. We've organized them in our own world into control families that you might have heard of, CIS, GDPR, HIPAA, NIST, et cetera. We have Fugue best practices in here where every time we perform an autopsy on a real breach in the real world or do a simulation of it, we look for ways we can use OPA to tell our customers if they have vulnerabilities that the bad guys used in that breach. And the answer is almost always that there are new things that we learn. So for example, IAM role assumption is a really scary one. And I think I'm going to do another talk somewhere in this conference about and show you and steal some data, and that'll be fun. Okay, so that's a little bit on how you can use it at the runtime, right? This is running infrastructure. But what about? Actually, I'm going to change gears here, and I'm going to say, what is OPA? I've described it, but let's. This is openpolicyagent.org. The Styra folks are the inventors of OPA and the maintainers of it. We mentioned before it's declarative policy, and here you can see it for Kubernetes, Envoy, and application code. But what I want to get to is this bit right here. So you've got some architectural flexibility. What OPA is, it's a language, and then it's an evaluation of that language in the runtime. You can use it in two modes, the same implementation. You can run it as a daemon and basically stand it up as its own microservice in your service architecture, or you can run it as a library. And this is really nice because, depending on what your use case is, one might be more appropriate. I mentioned we do lots and lots and lots of OPA evaluation. So we run as a library because we can't afford the network overhead. Right? It's got to be fast, so we bake it in. But you can also stand it up as a daemon, and then you have less policy to manage, right? In terms of where the policies live and so on. It's a really cool thing, and you can go. Let's go to their GitHub here, and it's written in Go code. And let's take a look at the adopters. So these are folks who are using OPA. And you'll recognize some of these names. Atlassian, BNY Mellon, Capital One, Chef, Cloudflare, Fugue, we're here. We were actually a very early adopter. This list has gotten much more impressive since we started, since we kind of signed up for using OPA. Goldman Sachs, Intuit, Netflix, Pinterest, so SAP, Yelp. When you're thinking about adopting an open source tool, and by the way, when you adopt a policy as code tool, you're making an investment that's going to last for a long time because you're going to build up a bunch of code, right? And replacing code is really expensive. I view all lines of code as financial liabilities to the company. They are things you're stuck to. Well, this should give you some ability to sleep at night knowing that this isn't going anywhere. And in fact, it's going to grow. So that's pretty cool. So yeah, go check out Open Policy Agent itself. I'll show you a couple of projects we've put out. And then and once I've given you this tour, I'm actually going to open a code editor and show you a little bit of code. But if you don't write code, don't be scared. It'll be fine. I'm going to be really, really explanatory. Okay. And you'll read some of these and you'll say, well, I could do that. All right. So Regula is for use with Terraform. And what it will do is when you do Terraform, you go through a step called the plan stage. Fugue Regula will then examine that plan against a collection of Rego policies, of OPA policies, and it will approve or reject it based on whether it breaks those policies. So you can see here we've built into the open source tool a bunch of stuff on AWS, GCP, and Azure. Making sure 3389 is an open and 22 is an open, and making sure KMS crypto keys are rotated at some reasonable frequency, etc. So a lot of this stuff comes out of the box. You need OPA and Terraform, or if you want, where is the link? Yeah, you can run it as a GitHub action. So GitHub actions, if you've not used them, are really cool. They're essentially spinning up containers in GitHub's infrastructure and running it for you. So you can just hit our GitHub action. You don't have to install anything, and you'll get that answer that way. But you can run it locally too. This is actually pretty much just a shell script and a whole bunch of work we did in Rego. Rego is quite powerful, and we've solved a lot of the kind of annoying things about writing infrastructure policies in Rego for you as libraries, but it's a very, very simple project. We also have out there a project, again, open source on GitHub, called Frego, which is the Fugue Rego toolkit. We wanted breakpoints. We're writing really fancy Rego at Fugue. We do a lot of this. So we wanted really good developer tools. So standard OPA comes with a REPL and some other tooling, but we wanted, like I said, breakpoints and the ability to go and change values and do the stuff that you do as a programmer when you're writing sophisticated things. So we wrote Frego. Frego also is a super fast evaluator of OPA policies on large data sets, which is a lot of what Fugue does. So it runs like 100 times faster than stock OPA for that large data set use case. This is all, you're welcome to contribute to these. I mentioned the other one is all Rego and OPA and a shell script. This one's written in Haskell. So if we have any Haskellers out there who are into policy as code, you can check this out. Okay, let's look at some actual code. All right, let's just walk through this real quick. In fact, I had pointed out this one to you when we were going through the GitHub repo. So this is the KMS rotate rule, right? So we can give it a name. We can call this package rules.kmsrotate. Well, that doesn't seem like a big deal unless you can't give things names, unless you can't organize things. And this is why having a real domain-specific language that's thought through and is full-featured it has those capabilities, okay? So here we're just defining a couple things. We're saying the resource type we're looking for is AWS KMS key. By the way, we can do this cool thing of mapping to controls, right? So this is mapped to CIS 2-8, and then we keep our own enumeration of the rules we're adding into Regula. All right, so this is just kind of the setup. And then here is the entire logic block. All right. So what we're saying here is default allow equal false, meaning by default, don't allow things, right? Allow equal false. And then we say, but allow if the input enable key rotation is true, right? Very simple declaration and gets you right to the point. So let's see if I can find, our team has been like cleaning up and organizing so much stuff in here that the big complex regos are now kind of abstracted into libraries. But this one's a little fancier, right? Here, our package is rules VPC flow log. And here we're doing an import. Okay, we can import libraries. It's a real language. And here we're saying the resource type is just multiple. In other words, we're going to deal with that as we go. We've got our control mapping. Hey, it's comments. Comments are important in source code. This is a real language. I'm going to keep saying that. But you need these features to have a maintainable set of code. And policy as code, you're going to live with it for a long time, right? So you have to have it be maintainable. So here we're just giving some explanation. Every flow log in the template. So flow logs equal fugue.resources. Now, why does it say fugue.resources? Because we've given you a bunch of libraries that, like fugue.rego right here, that are going to help you a lot. So here you can see we've done a lot of work to take all the fancy stuff and make it so you don't have to do that with regular. So one of the things I think is critically important when evaluating a language, I have like my first test. I don't care if it's imperative or functional or object oriented. They're all fine for different things. But the main thing I want to understand is it easy to do simple stuff? One, answer has to be yes. And two, can you do really sophisticated stuff, and does it hold up well in both of those use cases? And I'm very pleased that they designed Rego and OPA quite well, and the answer is yes. So I'm not going to walk you through all this code, but the important thing to take from this is even doing sophisticated things is possible, right? And this is not what this is 35 lines of code. It's not, and you know, a few of them are, it's probably 10 lines of actual logic in here. Not super hard to reason about, pretty easy, very easy to learn actually. And you can take advantage of stuff like all this work we've done in, you know, already abstracting things and things like Regula. And there are others out there doing this too. So some getting started resources. By the way, what I would suggest the best starting place is, and this is going to sound self-serving, but honestly, it will let you see what OPA can do without you having to invest any work, is if you go to fugue.co, let me show you this, you can get this kind of evaluation of your existing cloud infrastructure against, you know, all these control families in OPA. And you can also load your own OPA into Fugue, your own Rego, for your own controls. And then you don't have to worry at all about having to, you know, download OPA or learn the language. You can start experimenting with the capabilities right away. On the other hand, you can use the GitHub action on Regula if you're using Terraform super easily out of the box. Or, you know, if you're like me and you like to download source code and compile it yourself and really look under the hood, go to the GitHub repo at Open Policy Agent and have a blast. So these are the resources I showed you. I think that's about what I've got for you today. So thanks much for spending your time with me. And by the way, I'm Josh at Fugue, FUGUE.co. Feel free to reach out to me. And I try to answer everyone who does. So thanks very much.